Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, maximum product of splitted binary tree. So let us first read this question, then example, and then constraint, and then finally the coding part for the same. So here we can see that uh, hmm, given the root of a binary tree, split the binary tree into two sub-trees by removing one edge such that the product of the sum of the sub-trees is maximized. And return the maximum product of the sum of the two binary tree. Hmm, a net sub two subtrees. Since the answer may be too large, so we are required to return its modulo. Note that you need to maximize the answer before taking the mod, not after taking it, and not after taking it. So the thing is that we are required to figure out with whatever maximum we could find. Basically this tree which is being given to us. So we are required to split this tree into two subtrees, right? And after splitting means these two subtree should be split in such a manner that whatever sum we obtain from them, that should be in such a manner that when we do multiplication of them, so whatever product we get, that should be the maximum. So this is the thing which we are required to do. Now here we are just required to return that maximum product. We are not required to return that what edge we are splitting or what. So the thing is that what we can do here is that we can directly check for a particular, we can turn by turn check for the nodes that which node is most suitable for the same, and after that from that node one we can figure out with the sum of the one subpart of the tree, and then the other subpart of the tree could be figured out by getting it being subtracted from the total sum of the tree. So this is what we are required to do here. And as per the constraint, here we can see that number of nodes in the tree is in the range of 10 raised to power 4 in a value up to 10 raised to power 4. And we are then adding them up, and even the product which is there, so it can go up to 10 raised to power 8. So that's why they have told us to do modulo. And the number of nodes is 10 raised to power 4. So as per this, our solution, which we will be performing here, basically it can be easily done in n order of n solution, because we will be directly doing DFS here for each node which is being there, so that we can figure out that this particular sub part, and this will be figured out after getting this part from the total minus whatever we got from this particular. So that is how we will be moving ahead with this particular solution. So the time complexity for the same solution would be order of n, and why order of n it would be? It would be because of the DFS which we will be performing. So the thing is, what we will be doing here is that first we will be doing DFS on whole tree, and this will let us know the sum for the whole tree. Basically total sum of the tree that we will be getting here. Then we will be performing DFS on subparts of the tree, and that subparts would be on the basis of a particular node, and because of that node only we will be able to figure out the sum for a particular subtree. And after getting these two things, what we are required to do next is, then without performing DFS also, we can now, after getting that total sum minus whatever that other subpart of the, basically the other subtree sum which would be there, we can subtract that, and then we from this only we can get the second subtree sum. So these are the things which we are required to do in this particular question. And then after getting these two things, we can easily get whatever product would be there, and we will be just getting by whatever maximum product is there. We will be comparing that. So that is how we will be doing this question. Now here comes the part for the implementation part of the same. So here we have taken these two global variables, result and total three global variables. And then here we are checking for this total. So here total is for the first we are checking from this particular whatever the total sum is there, we are doing basically DFS here. That sub is equal to root val, then sum from the left subtree and sum from the right subtree. That's what we are doing in this particular. And then here we are checking for the whatever till now we got the maximum product, so that we are checking at this point. But the thing here is that when the first time this particular is being called, right? So we will be just able to calculate whatever total is there. But then we are again required to call, because when we are calling this, then at this moment we will be having answer for a total as well. Means total would be having some value as well, right? So when we call this second time, so at that moment we will be able to calculate our result as well. So that's why we are calling here two times, and because of this, here we are what we are doing, how we are calculating the result is result whatever we have been storing till now, maximum of that, and the newer value which would be there means the sub part at that moment multiply by whatever remaining is there, because how we were calculating here for the remaining part was by this, right? And then after that we are required to do the product, and that's what we are doing at this particular step. And then here, the sub which is being returned, this will be acting as means if we are passing this particular one, right? And this is at that subtree. So now it will be going to this point. It had gone to this point, but here it was null, so that's why it was being returned here, right? So this is how what it is being returned at this point to the parent caller, and thus it will be giving our answer. So this is how it was required to be done in this particular question. So time complexity is basically order of n only, and the space complexity here, that is as per the recursive stack. So as per recursive stack, the space complexity is order of n as well. So yeah, this was all for this particular question. If you have any doubt, you can comment that down. So yeah, thank you.